Where'd I start? Okay, anyhow, I thought I had the camera on, but I didn't, so who knows when I might have had it on, what I did. Could be embarrassing. Okay. So in the typical case, C1 is some multiple of C3, C2 is some multiple of C3, right? And C3 could be anything. So the solution doesn't require that all the C's be 0. Okay? If C3 is anything but 0, then none of them are 0 in this case, if these aren't 0. So we say that unless both of these are 0, there are infinitely many solutions. There's a solution for any value of C3, and not all the CI's are 0. Matter of fact, none of them would be. Now, if we reduce to this form, then we can conclude that C1 is 0, C2 is 0. But we can't conclude anything about C3, so it can still be anything. So not all of them are 0. Not necessarily, they could be, but this says they have to be. Okay? So again, we contradicted the condition for linear independence. Okay? Okay, well that's a very important idea, the idea of linear independence. Now there are other ways these things could reduce, and I think I just said this. If this is 0 but this one isn't, or this is 0 but this one isn't, right? Or maybe the second row just cancels out altogether. Well, in any of those cases, you have the same thing. At least C3 would be a free variable in any of those cases. And you can work that out. You have to be able to recognize that. Okay? So if you're fuzzy in that, two things. One, don't jump from this to this out of habit. Okay? Unless you've totally thought it through and understand every step that connects this to this with the definition. Okay? Because there's always a temptation to get through the homework, so let's just write down what I know worked last time. Develop a habit without thinking it through, and the habit doesn't always work. Okay? Think it through. It's not that hard. If you keep thinking this through, it'll become natural. And you won't make the kind of mistakes that I've seen too many of already on the test. Okay? There are other things you can do to avoid the mistakes, but this is the big one. Connect everything, one step at a time. Now, what's another possibility for this system? Well, it's really easy to see that the system that we had over there could be written as a matrix equation, right? So our system of equations gives us a matrix equation, which would be 2, 3, 1, 5, 4, 6, multiplied by C1, C2, C3 equals 0, 0, 0. Okay? What do you do with a matrix equation like this? Well, if it's a square matrix, which it isn't, but if it's a square matrix, then you can check its determinant to see if there's going to be a solution, right? Okay? So, but this isn't square. Excuse me, not a square matrix. So you would use the augmented matrix. Even if this is all you see, you know that to solve this, you go to the augmented matrix, right? Okay? Or you go to the system of equations and then the augmented matrix. And you should think that through, because you can see what the system would be. You can visualize it and say, okay, it's the augmented matrix. And if you can't visualize it, you need to write it down at least a dozen times before it sticks with you. Now, maybe some of you need to write it 10 dozen times. Maybe some people can get by writing it once or twice. Okay? Depends, but don't overestimate your ability to remember the essential things, right? Practice. And keep writing things up. Don't skip steps. You have to keep reinforcing the connections or you lose them and make mistakes on tests. Okay? Okay. Now, if it was a square matrix, what would we do? Okay, well, let me give you another set that does give you a square matrix.